we have what is the basic difference between laser and ordinary light. What makes a laser a specific coherent source or the traditional coherent source of choice? Most importantly, once again, it's a unidirectional. So it goes in only in forward direction, unlike the ordinary light flashlight which we consider. And most importantly, it is of single wavelength. So the single wavelength, and obviously the frequency is constant for a specific set of, for the specific velocity. As contrary to the laser, a flashlight is made up of white light. Okay, and we are already familiar with the concept of dispersion. So it is actually multicolored. Now, when we say it is multicolored, means it is of many different wavelengths. अभी coherence में क्या चाहिए हम लोगों को? In coherence, we need there should be of same frequency and same wavelength, single wavelength preferably. So we have different wavelengths, so obviously it's not going to happen. Another thing, it is not unidirectional, but it is multi-directional. Even though we might not be able to see it, the focus of a flashlight is not like this, but it goes into, let's say, this broad spectrum for that matter. Whereas laser, if we consider, only this is the way the laser we will get. Whereas light in flashlight, it will go in upward direction, it will go in downward direction as well. It will go in the front direction as well. Thoda idhar bhi jayega, thoda udhar bhi jayega. Means it is not in a single direction. It is in different directions, which makes this incoherent source. And that's why whenever we have lots of light interfering with one another, even in our house, we are not able to see an interference pattern because those sources which we are using are incoherent sources. So, before moving forward, do we have any doubts in coherence for that matter? Bolo yes or no? Okay, good. Now, moving forward, we are actually going to understand and we are actually going to see and analyze the actual interference pattern which is formed. Now, how this particular concept is being analyzed? It is analyzed by performing an experiment which was performed by a scientist named Thomas Young. The experiment is called as Young's double slit experiment. And the diagram, it goes something like this. Again, as you can see, I've taken this diagram from your textbook itself. Now, this Young's double slit experiment, what happens in this particular double slit experiment? Okay. So before going or dwelling into the details, analytical details of this particular experiment, we are going to see a particular GIF, okay, which gives you what exactly happens in this particular experiment. It looks something like this. Okay. Now backing up a little bit, what happens over here? Look at this S. What is this S? S acts as a primary source of light. Now this primary source of light, it emits light. We have a lens over here, convex lens, which undergoes a conversion and it reaches this particular point. Okay. Now what are these two? These two are small slits. Okay. Now small slits means what? They're small openings. Okay. If I am to show you in the front part, if this is a, let's say, a piece of cardboard, then we have some small opening of this type. And this is what we call it as a slits, which is S1 and S2. Now, when the light from the primary source S, it reaches S1 and S2, some light will pass through S1 and some light will pass through S2. And these S1 and S2, they act as secondary sources of light. And these secondary sources of light, they're going to produce their own waves with again crest and trough and so on and so forth. Now these S1 and S2, these slits, they form coherent source of light. So we have two secondary sources, to be precise, two secondary coherent sources of light. And these coherent sources of light, when they undergo superposition, they interfere with one another, giving us the perfect interference pattern of high and low intensity. So just like before we have seen, when the constructive interference, these blue dots, they represent a constructive interference. So you can see the intensity is maximum, and we called this point as a bright point. These red dots, they represent a destructive interference. So you can see the intensity is minimum. We called it as a dark point. So you can see it has alternate bright and dark, as in maximum and minimum points. So we have alternate bright and dark bands over here, which are formed due to the consecutive constructive and destructive interference. And we get a bright and dark pattern in this format, which is shown over here. So you have a dark band and you have a bright band. Again, you have a dark band. Again, you have a bright band, so on and so forth. So this is bright band, which has two adjacent dark bands. And this final part, this is what we call it as a interference pattern. Any doubts in this? This is how the interference pattern it looks like. Alternate dark and bright bands. Bolo, yes or no? Okay, good. Now the same part which I have explained, this is what we are able to see over here. Now at the start of it, I told you that this is what was given on the surface of water. So how it looks on the surface of water, this is how it looks on the surface of water. Okay, ये दिख रहा है रे सब लोगों को? बोलो रे yes or no? So you can see over here, see, this we can consider as a constructive interference, and this lines which we have in between, like this is what we have as a destructive interference. This line which we have over here, again this we can consider as a destructive interference. Matlab kya, if we use this analogy to our light ka part, this is what we have as a bright band, and this is what we have as a, well, dark band. Again, this is what we have as a dark band. Again, we get a bright band over here and a bright band over here, so on and so forth. So this is how we can produce it on the surface of the water. Okay, if you want, you also can try and do that. You take two fingers and dip it in the bucket and move them simultaneously in the water. The ripples which are caused due to those fingers, you will get this particular interference pattern. चाहे तो घर पे कर सकते हो तो. Okay. So what exactly is this particular experiment we have already seen. I've already explained it to you, so we can quickly go through this particular experiment. What we have S as a primary source. To be precise, it's a linear source. Light travels in a straight line. That's why linear source. And S1 and S2 are the narrow slits. Now, narrow slits, why we have narrow slits? They act as a secondary source of light. The light waves which are coming out from S1 and S2, they are in phase, stressed on the subject, stressed on the word in. That's why we have coherent sources. And finally, a PQ, we can see this is PQ. This is the screen which we have. So what happens? Now we already have seen this. So blue dots, this blue dots, what we have, a crest on a crest or a trough on a trough. So what we get? A constructive interference which gives rise to high intensity, means we consider it to be a bright point, which we have already seen. Vice versa, we have red dots, which is crest on a trough, or other way around, trough on a crest. We get a destructive interference. We call it as a dark point or a dark band, we can say. So these are called as alternate dark and bright bands, or alternate dark and bright points, or a specific terminology it is used as a dark and bright fringes. So fringe matlab kya? Fringe matlab band in this context. So the dark fringe and a bright fringe, or a dark band and a bright band. So this entire part which is formed on the screen, a consecutive dark and bright fringes, this whole dark and bright pattern is what we call it as an interference pattern. And this is how the interference pattern it looks like. So any doubts in this particular concept? Bol rahe yes or no? किधर गए रे बाकी के? कल्याणी, नीरज, सुजल, आयुष. Okay, good. So moving forward, we have a derivation. Again, we are going to see the geometry and the analytical part of this particular interference pattern. So again, to avoid confusion, I don't want to start derivation now, because again, I want to complete it in one sitting. So even though we are not at that particular time, we'll stop over here today, and we will continue this in the next lecture. Okay. So once again, please keep on revising whatever we have done till this point. And again, just a reminder, I'm not getting your notes properly. Only a couple of students are only sending me notes. I want to see whether you have written it or not. So today is Friday. So now we will have lecture on Monday once again. So before Monday, I want to see all of your notes completed till this point, till interference pattern. Okay? समझा नहीं समझा रे? बाकी लोगों का नहीं आया रिप्लाई, 3 ही लोगों का रिप्लाई आया. किधर गए बाकी लोग? हाँ, मंडे को चाहिए मुझे, मंडे तक चाहिए, विदाउट फेल. ओके. Chalo. So today we'll stop over here. I won't start with the new derivation now. So I hope you have understood whatever we have done.